Hello everyone. Today we are going to start the building material. So first topic is brick. So these topics we are going to cover. Okay. First of all, importance of brick, manufacturing process of brick. Third is taste on brick. Fourth are classification of bricks. So we will cover these four topics. So first of all, brick. So bricks are basically molded clay, which are molded clay in which are molded in rectangular form and which are commonly used for construction of engineering structures. Now second thing is composition of good brick. So there is lime, alumina, silica, lime, iron oxide and magnesia. These all ingredients are present in earth. Okay. So first of all, alumina. Alumina it is main component of a clay. So alumina should be present in good building at from 20 to 30%. Okay, it gives the plasticity to the brick earth. Okay, so alumina is generally we can say it is a clay or alumina is mainly present in clay. So percentage of alumina should be 20 to 30%. It gives the plasticity, okay, to the brick at the time of molding. But excess quantity of this alumina will cause the shrinkage of the brick. Shrinkage means after drying, the size of and shape might be changed or compressed. So this is the property of alumina or clay. Second thing is silica. It is mainly present in sand. Okay. So percentage of silica should be vary from 50 to 60%. Okay, it is the main ingredient of bricker. It prevents the cracking and shrinkage of the brick. Okay, if the quantity of silica or sand will be more in bricker, that time brick become brittle. Okay. Third thing is lime. The percentage of lime should be less minimum or less than 5%. Here it should be 5%. Okay. So percentage of lime should be less than 5%. In fact, it should be present in finely powdered shape because it might be absorb the water from atmosphere. So it prevents the shrinkage and help in binding. Actually, it is a function of lime. Okay. If If the lime is present in excess quantity, it will swell and brick might be disintegrated. Third thing is iron oxide. It should be present in brick earth from 4 to 5%. It gives the red color to the brick. It gives the red color to the brick. If the quantity of iron oxide will be less, that time less than this quantity, that time color of brick might be yellowish. Okay. Last is magnesia. Small quantity of magnesia is required in brick if impart the yellow tint color. Okay, and also decreases the shrinkage. But excess magnesia leads to decay of brick. So these are the ingredients: lime, silica, alumina, iron oxide, and magnesia. Okay, so percentage we have to remember the percentage of these ingredients and their function. And if their quantity will be excess, that time what will be the effect on the brick. So this table we have to memorize. Okay. Now, manufacturing process of brick. As we know, the bricks are generally prepared from soil. And soil will be molded in desired shape, and the molded shape, molded molded soil will be dried in sun rays, and then after that it will be burned in kilns. So these are the procedure: preparation of clay, then molding of clay into desired form, and then there will be drying, and after drying there will be burning at 100 to 1100 degree centigrade. Okay, here it should be degree centigrade. Okay, last thing we have to study about the harmful ingredients present in brick earth. So these are the harmful ingredients which are present in the earth. First of all, we are going to discuss on vegetations and organic matter. Suppose these organic matter and or vegetations will be present in the brick earth. So at the time of burning, yeah, after molding, it will be there. Means organic matter will be available up to this point. But suppose there is harmful organic matter present in here. So at the time of burning, at this temperature, all the organic matter will be burned, and inside the brick there will be cavity of so for avoiding this, there should be not any vegetation or organic matter in the brick earth. Okay, we have already discussed the excess quantity of lime, and lime is harmful in brick. Okay, because it causes unsoundness. Unsoundness means uh, it small impact, it will be breakdown. So the quantity of lime should be minimum or less than 5% is desirable. Iron pyrites, actually if iron pyrites is present in the brick earth, the bricks get crystallized and disintegrated during the burning. At the time of burning, brick might be disintegrated. Okay, alkalines. Suppose alkalines are present in brick earth, then bricks will absorb the moisture from atmosphere when they are used in masonry. Okay, if we are using the brick structure, it might absorb the water from atmosphere. That's why alkaline should be not present in brick. Okay, pebbles. Uh, actually, the brick are made of clay and earthen material. Okay, I mean soil. So it should be uniform texture inside the brick. If pebbles are present in the brick, so the structure of the brick will be not uniform. And sometimes what will happen, we will cut the brick in desired shape, but due to presence of pebbles, we are not able to cut it in desired shape. That's why pebbles should not be present in brick earth. Okay. Now, size and weight of brick. Actually, weight of brick is generally vary from 3 to 3.5 kg. Okay. It is the variation of brick. Okay, weight of brick. Now, there are two types of size of brick: standard size and nominal size. First of all, size means there is one, we will consider one brick. So this size of this brick will consider as a standard size. But suppose we are using it in wall, that time there will be one layer of cement mortar. Actually, mortar is mixture of cement and sand plus water. So this layer is there. Okay, cement mortar layer is there. So when we will consider this thickness of this mortar also, means around the brick there is one thickness of brick. So center to center distance of this mortar, means with mortar we are considering the size of brick with mortar. So it will be model nominal size. Okay, so standard size of brick is 19 centimeter by 9 centimeter by 9 centimeter. Okay, so it will be 9 centimeter by 9 centimeter by 19. But in modular size, nominal size brick, we will consider it with mortar. So there will be increase of 1 centimeter in all dimension. So 19 will be converted into 20, 9 will be converted into 10, 9 will be converted into 10. So nominal size will be 10, 10, 20. Okay. Now quality of wood brick. Quality of good brick. Okay, shape and size. Shape and size of the brick should be uniform with straight edges. Okay, edges should be straight and size should be uniform. Color of the brick should be deep red. Texture should be no fisheries or holes should be present in the brick. Okay, hardness and soundness. We will discuss this test later. Compressive strength. Compressive strength of good brick should not be less than 10.5. Means it should be 10. We will discuss it later, okay? Because first of all, we have to study about the testing. So these are the tests. On the basis of test, there is classification. So first of all, field test. Okay, so on the field test there is hardness test, strength test, soundness test, and color test, and size test. Okay, and second things is there lab. The second category of tests are lab test. On the basis of lab test, we are doing means basis of these tests. We are going to classify the bricks on in the basis category of first class, second class, third class, and fourth class. So first of all, hardness test. What is the hardness test? How to calculate the hardness on the field? Okay, actually, it is these are the field tests. So we will measure this parameter on fields itself. So in hardness test, what we will do, we will mark a scratch on the surface of brick. Okay, by using fingernail, we will mark a scratch by finger on the brick surface. If the scratch is visible, that time brick is big. So there should not be any visible mark of fingernail scratch on the surface of earth. Okay. Second, strength test. How to measure the strength of brick on field? So what we will do, we will drop a brick from 1 meter height on a hard surface. Okay. We will drop a brick from 1 meter height, 1 meter height on a hard floor. So if brick is strong enough, it will not break down. If brick is weak, that time it will be break down on the hard surface. So there only 1 meter height we have to remember. Okay. In third one is soundness test. In soundness test, we will stack two bricks. Okay, stack two bricks. um, in soundness test, we will stack two bricks to each other, and during this procedure, there should this brick should not be break down, and there should be clear metallic ringing sound should be audible. So this is the procedure for soundness test. In this state, two bricks are taken and they are struck together. Wait for a minute. Soundness test. In this test, two bricks are taken and they are stuck together with. Okay, the brick should not be break and clear ringing sound should be audible. So if the dull sound is there, that time we can say it is a big brick, or brick might be breakdown. So clear ringing sound should be audible or metallic sound should be visible. Color test. Okay, the color, we will break a brick. Okay, actually we can say it is a texture or color test, but when we will see the cross section of brick, so color should be uniform throughout the brick. Means it should not be like the burning of brick should not be take place only outer area. Okay, it should be uniform cross section throughout the brick. Last test is size test. Okay, in this test, what we will do, we will arrange the 20 bricks, uh, 20 bricks in widthwise. Okay, in such a way, we will arrange the 20 bricks in cross lengthwise, widthwise. Okay, and depthwise. Okay, so size of one brick is 9 centimeter widthwise. Lengthwise, it is 19 centimeter. So for 20 bricks, it will be 19 into 20. For along this total length will be 19 into 20. For 20 brick along the width, it should be 9 into 20. Okay. For breadth wise, it should be 9 into 20. So overall, it is 180 centimeter and it is 80 centimeter. Okay, it should be if they are having the standard size, but there is tolerance limit. It should be, it might be 12 centimeter less or 12 centimeter more. Beyond this range, this variation should not be there. There should not be variation more than 12 centimeter along the length and 6 centimeter along the width and breadth. So 9 into 20, it will be 180. So plus 6 centimeter minus 6 centimeter is allowable. Okay. So these are the field test. Okay. Now come to the lab test. Compressive strength, water absorption, and efflorescence test. We are going to discuss it one by one. Okay. These tests are performed by as per the IS 3495/1992. Okay. This is the IS code which we will follow. Okay. So what we will do, we will first of all put the brick for 24. So, actually, compressive strength test generally we will conduct for some samples. So minimum 3 samples we have to test. So we will put the brick in water for 24 hours, and after that we will fill the that frog. Okay, on the surface of brick there is one frog, so we have to fill the frog by using 1:3 cement mortar ratio. We will fill the frog, okay, on the surface of brick. So one frog is there, so if we will directly apply the load, this frog means this area will not take any load, so we have to fill this frog by using mortar. More of the ratio 1:3 means 1 part cement and 3 parts Okay. And after the filling it by mortar, again we will cover the brick by using wet gunny bag, and because this mortar will take time for hardening. So after proper setting of this mortar, what we will do after 3 days, okay, we will put the this brick in water so that this mortar will properly set. After taking the brick from water, we will clean the surfaces of brick, okay, and we will put the brick in between two plywood, okay, and we will apply the loading. Why we are doing this procedure? Because we want to apply the load on total brick. Not if we will not fill this top, it will not participate in loading. That's why we are filling the gap by using mortar. Okay. Load intensity will be uniform rate of 14 Newton per mm square. This will be variation of load variation of the loading rate of loading, because if we are doing this, it is to avoid the impact load. Okay, and we will measure the load at failure. So suppose the cross section area is measured, so we will measure this length and width. And load compressive strength will be load at failure divided by cross section area. So this procedure we have to follow. First of all, we will put the brick in water for 24 hours. Then we will fill the fog by using 1:3 mortar. Then for 24 hours we will put the brick in damp climate, and after that for 3 days again we will put the brick in water. When we will after 3 days we will take the brick out the water. We will clean all the surfaces by using damp cloth. Actually, we are doing this procedure only for applying uniform loading. Okay, so we will put this brick in between two plies, and we will put this setup in CTM. CTM means compression testing machine at the rate, and we will apply the loading at the rate of 14 Newton per mm square. Okay, so and we will apply the load until the brick will get failed. So load at failure divided by cross section area, we will get the compressive strength of brick. Okay, so suppose this is the cross section area, so it will be width and this will be length. So at this area we will apply the loading. So load at failure divided by cross section area. Okay, so minimum strength of brick should be 3.5 Newton per mm square. Second test is water absorption test. For water absorption test, we will first of all we will take a dry brick. How we will get the dry brick? We will put the brick in oven to achieve a constant weight. Means to that time we will put the brick in oven. After that, there should not be any weight variation. Okay, we will put the brick in water oven at a temperature of 100 to 115 degrees centigrade. Okay, then this brick will put in water for 24 hours. After 24 hours, we will take the brick out of water and we will clean the surfaces of brick. And within 3 minutes, we will take the weight of weight brick. Okay, so dry weight and weight. Okay, so change in weight will be water absorbed by the water by the brick, water absorbed by the brick, and divided by initial weight or weight of dry brake multiplied by 100. So we will get the percentage of water absorbed. Okay. So IS code recommends that what any brake should not be absorb water more than 20%. Our good brake should not be absorb water more than 20%. Efflorescence test. Efflorescence test is used to measure the soluble salt present in the brake. Okay. So what we will do, we will put the we will take a tray and fill the tray up to 2.5 centimeter of water. Okay, we will fill this tray by 2.5 centimeter of water, and we will keep the brick in such a condition that the 2.5 centimeter portion of the brick will be submerged in the water. Okay. After drying all the water, okay, we, after some time this water will be dry. So we will again replace the water. Okay, again we will fill the water up to 2.5 centimeter. So two times we will change it. Water means initially what any water will absorb by the pig. Again we will replace the water and we will measure. Okay, suppose the effluent. What is the meaning of effluent? Suppose these soluble salts are present in this soil of the brick. Okay, so due to absorption of water or this humidity, the salt will be comes out from the brick to surface of the brick. Like you can see here, salt are easily visible on the surface of the brick. So we will measure the area which is covered by the salt on the brick. So if there is not any precipitate visible on the surface of brick, that time we will say it is a nil efflorescence is there. If 10% area is covered by the efflorescence or soluble salt, so we will say it is slightly efflorescence test means result is slight. Moderate means up to 50% area covered by the salt. Heavy efflorescence means the complete area or more than 50% area is covered by the salt. Okay, this is the typical result table where the water absorption, efflorescence, and compressive strength of the bricks are given. Okay, and the last we will take the average of brick number of bricks. So advantages of brick. Okay, brick. It is up to you. Please read these things. Now I am coming here. Classification of brick. Okay. Before this, I am asking you simple question. What should be the quality of good building brick? So compressive strength should be maximum. Water absorption should be minimum. Efflorescence should be minimum. Size should be uniform. Color should be uniform. Soundness means when we will strike the brick to each other, that time clear ringing sound should be audible. Strength means when we will drop a brick from 1 meter height, it should not be break down. And hardness means when we will mark a scratch on the surface of brick, so that time it should not be visible. Means there should not be any impression of fingernail on the surface of brick. Now classification of brick. Okay, so first class brick is superior quality brick. So I am writing here some technical data. Okay, first class brick should have strength more than 10 Newton per mm square. Okay. Second class brick should have the strength between 7.5 to 10 Newton per mm square. Okay. And third class brick should means below 7.5, we will consider it is a third class brick. So these are the strength, okay. And minimum strength of brick should be 3.5, okay. So these are the classification based on strength. Now water absorption. First class brick should not absorb water more than 20%. Okay. Or it should be absorbed less than 20%. Second class brick will absorb the water in between 20 to 22.5. Okay. And third class brick absorb the water by 25%. Okay. We will not consider fourth class brick right now because it will fail somewhere, means strength is less. This is also more. Efflorescence. Okay, efflorescence is not play any role for classification, but efflorescence should be minimum. Suppose at any place we are using the brick where chemical or it is exposed to the surface, that time it will react with the, it should not react with the any atmosphere. Now first class bricks are, means what should be the quality of first class brick? Okay, so first class brick should be uniform shape and size. Okay, they means they are properly bronzed. The surface and edges of the bricks are sharp, square, and smooth. And first class brick have the quality of all good brick. Okay, and these bricks are can be used for all kind of permanent work. Second class bricks are table mounted, but there are some minor defects, and everything is fine with second class also, but it might be fail in strength or water absorption, or any cracks are visible, or color will be defective, means minor defects are there. In third class brick, they are failing strength, they are failing in water absorption, if they are failing in color, they are failing in soundness, they are failing in hardness. Okay, so these are the classification of first class, second class, and third class. Okay, fourth class bricks are generally they are used as a aggregate in or road metal for filling the foundations and pier, etc. Okay, road metal. So we are using fourth class brick as a stones for filling the railway tracks, etc., etc. Okay, we will not use it for building construction or wall construction. We will use it in some places where the hard material are required. So hope you understand the topic and how to solve it. I will share the PPT on Telegram. Okay, thank you very much for joining the class. Have a nice day.